This video is for Lesson 13-2, Isosceles Triangles. Learning goals are to develop theorems about isosceles triangles and to prove those theorems. Let's make believe that some of the triangles Jason needs to replace on the rock and roll building are isosceles triangles. Again, he thinks he knows what an isosceles triangle is, but he wants to be sure he's correct. So number one, let's define an isosceles triangle. An isosceles triangle is a triangle with at least two congruent sides. Here's a drawing of an isosceles triangle. We're asked to label the sides and angles using these vocabulary words. The angle at the top here is called the vertex angle. The other two angles are called base angles. The base angles are formed by the legs meeting the base. So that angle's a base angle, that angle's a base angle. The side here is called the base, the other two sides are called the legs. Number two, draw and cut out an isosceles triangle, and then fold your triangle so the legs coincide. Let's just make believe that we did that without actually cutting one out with scissors out of paper. So if we drew an isosceles triangle, a triangle that had two sides equal, imagine cutting it out and then folding it right down there so that the right side flipped over and landed perfectly on the left side. Number four, list the conjectures about relationships you observe in the angles of the isosceles triangle. I think when I fold this over that this angle would coincide perfectly with this one, that those base angles are congruent. Number five says, write that conjecture in if-then form. And this is known as the isosceles triangle theorem. So I'm going to take that idea, the base angles are congruent, rewrite it, but with the words if and then. How about like this? If a triangle is isosceles, then the base angles are congruent. That's the isosceles triangle theorem. The proof of this theorem begins by drawing the bisector of the vertex angle. So here we have the diagram, and then the purple line is the bisector of angle B. That and that are equal. Because it's an isosceles triangle, we know that that leg is congruent to that leg. And as soon as we split it down the middle, it creates two triangles. I think that those two triangles are congruent by SAS. We have a side marked, and then an angle, and then certainly the side that's shared between them is congruent. So SAS is our criterion. Because this triangle is congruent to this triangle, then we know that this angle is congruent to this angle, because corresponding parts of congruent triangles are congruent. CP-CTC is a quick way to write that phrase. Corresponding parts of congruent triangles are congruent. Let's work a few problems about isosceles triangles. The measure of the vertex angle of an isosceles triangle is 80 degrees. What is the measure of a base angle? So if I make a quick sketch of an isosceles triangle, so I want it to look like it has these two equal sides, we're told the vertex angle is 80. And we're asked for this angle and this angle, the base angles. Well, we know that the base angles are congruent, and we know that the top one is 80. If all three of them add up to 180, then these must be 50 degrees. 50 plus 50 plus 80 is 180. Number 8. The measure of one base angle of an isosceles triangle is 25 degrees. What's the measure of the vertex angle? So again, a quick sketch. If we're told that the base angles are 25 degrees, can we find the missing vertex angle? 25 plus 25 is 50, so this one must be 130 degrees. Again, they all will add up to 180. Next question, solve for x. So a very similar problem, but in the angles we have some algebra expressions. This is an isosceles triangle. I know that because these sides are congruent. This base angle is congruent to this base angle, so we can put 2x plus 3 in here as well. Remember that all three angles will add up to 180, and that's how we can get our equation. 3x minus 1 plus 2x plus 3 plus 2x plus 3 equals 180. 3x plus 2x is 7x. -1 plus 3 is 5, and that's equal to 180. Therefore, 7x is equal to 175. And then dividing by 7, 7 into 17 twice with 3 left over, 7 into 35, 5 times. X equals 25. We were asked to solve for x, so we have it. Number 10, using the figure below, and that segment PQ is congruent to segment PR, so that's congruent to that. And segment TQ is congruent to TR, so that one's congruent to that one. Explain why angle 1 must be congruent to angle 2. Our explanation might go something like this. We know that this angle is congruent to this angle because of the Isosceles Triangle theorem. And so that's what I've written out right here. Next, if we look at the small triangle, we know that this angle is congruent to this angle. Again, because of the Isosceles Triangle theorem. When you have an isosceles triangle, the base angles are congruent. Final step, go back to this first equation. And because the measure of angle 3 is equal to the measure of angle 4, we can subtract angle 3 from the left and subtract angle 4 from the right, leaving the measure of angle 1 is equal to the measure of angle 2. Number 11, use the isosceles triangle theorem to explain why an equilateral triangle must be equiangular. So an equilateral triangle is a triangle where all 3 sides are congruent. An equilateral triangle is an isosceles triangle, and in this particular case, any one of these might be called the base and the other 2 might be called the legs. So having 3 congruent sides implies that there would be 3 congruent angles. Number 12, Carly said that if an isosceles triangle is obtuse, then the obtuse angle must be the vertex. Is she correct? Yes, she is, because there can't be 2 obtuse angles in a triangle. Obtuse angles are greater than 90 degrees, so you can't have 2 of those. You can't have 2 angles that are both greater than 90 degrees and still have the 3 angles add up to only 180. That wouldn't make any sense. Number 13, write the converse of the isosceles triangle theorem. So let's take the isosceles triangle theorem, just reverse the order of the sentence. It might look something like this. If 2 angles of a triangle are congruent, then the triangle is isosceles. Is that true? Yes, that's always true. So that's a way to find out if a triangle is isosceles. Look to see if 2 angles are congruent. Number 14, in triangle ABC, angle A is congruent to angle C. So if we draw a quick sketch of this, that fact helps us to know that this base angle is where A is, and that this base angle is where C is, because these are the ones that are congruent. And then we know that it's the letter B, that's the vertex angle. Now we can label the sides. AB is 4x plus 25. BC is 2x plus 45. And AC is 3x minus 15. This is an isosceles triangle, so this leg is congruent to this leg. These algebra expressions are equal to each other. And that's how we get an equation. Drawing the picture helps us to know how to build this equation. Notice that the base 3x minus 15 isn't in our equation. If we hadn't have drawn the picture, we maybe wouldn't have been able to get the equation. This creates 2x equals 20, therefore x equals 10. And once we have the answer for x, you can substitute it in here, here, and here to find the 3 sides. Number 15, look at the fold in your cutout triangle. So we didn't actually cut a triangle out, but we just thought in our minds what it would look like. So it would be a triangle like this, and then folded right down the middle. What appears to be true about this segment? Well, it would intersect the base at a 90-degree angle, and it looks like it touches the exact midpoint of the base. So question B, what geometric term could be used to classify that segment? We could call it the perpendicular bisector. Here are some check your understanding questions, so I'll pause the video. In this lesson, we developed some theorems involving isosceles triangles. One was the isosceles triangle theorem that said if you have an isosceles triangle, then the base angles are congruent. The converse of that is also true. If you have a triangle with congruent angles, then you know it's an isosceles triangle.